Machine learning, ML, an art and subset of artificial intelligence dedicated to the formal study of learning systems. Machine learning is a methodology of performing data analysis which automates an analytical model. In other words, machine learning is all about learning to do a task better in the future based upon its previous learned patterns in the past. ML, being a subsection of artificial intelligence, provides systems/computers with the power to learn without being explicitly programmed. One of the reasons why ML is picking up traction in the IT world is because as and when patterns are developed with new data, ML algorithms has the ability to independently adapt and learn from the data and information. With ML, computers are not being programmed but are altering and refining algorithms by themselves. Looking at other definitions, ML discovers the study and construction of algorithms that can learn and make predictions of data. In other words, it focuses on prediction making through the use of computers. With the rise in new generation technologies being witnessed in the 21st century, ML today is something that cannot be compared to what it used to be in the historical past. The past has been witnessed in the rise of various ML algorithms and the complexity of the calculations being carried out. However, it is just during the recent times, the recent ML algorithms have been tuned in such fashion that the whole complex mathematical calculations, analyzing big data at a much greater and faster, a very recent development. Some of the underneath examples, but not limited to, have adapted ML within their service space. Google's self-driving cars, ML algorithms are used to create models in classifying various types of objects in different situations. Netflix, ML is used in improving the member experience. Twitter, ML is being applied to enhance its video strength. An immense amount of popularity is being gained over data mining and Bayesian analysis due to a fast-paced adaptation of ML in solving business problems. Computational power, availability and various type of data, cheap and powerful data storage is ever growing, which is some of the few attractive factors towards adapting ML. What this means is that it is quickly possible to fire up an automated predictive model which can analyze larger and complex datasets and deliver accurate final outcomes. This results in an additional value towards predictions, which leads in creating smarter real-time decisions without human intervention. Within the software vertical, artificial intelligence is being a popular technology to integrate within a service as the mandate for analytics is motivated more by growth in type of both structured and unstructured data. In the 1930s and 1940s, the pioneers of computing, such as Alan Turing, began framing and playing with the most basic aspects of ML, such as a neural network, which has made today's ML probable. As per, humans create couple of models every week. With ML, thousands of models are created within a week. Upsurge in computing power is one of the prime reason from a transformational shift from theoretical to practical implementation. High number of researchers and industry expertise are contributing towards the advancements in this space, as it is constantly being used in solving some real issues across industries including, but not limited to, healthcare, automotive, financial service, cloud, oil and gas, governments, and so on. Data, be it small or large, residing within these types of industries contain a large number of patterns and insights. ML creates the ability to discover various patterns and trends within these, giving rises to substantial results. The rise of cloud computing, massive data storage, devices connecting with each other, Internet of Things, and mobile devices play a huge role in the adoption of ML. Supervised learning, algorithms are trained on labeled data, essentially leading to its meanings where an input having a looked-for output. In other words, a supervised learning algorithm with an input variable denoted as P and an output variable denoted as Q, and algorithms are used to create and learn a mapping function, F, via the input to the output. The goal of a supervised learning algorithm is to achieve an estimate mapping function so that for every new input, P, a new predicted output, Q, is created. In other words, the learning algorithm receives a set of inputs with their corresponding outputs, and the algorithm learns by equating its concrete output with correct outputs in order to find errors and have the learning model modified accordingly. Supervised learning algorithms make use of patterns to predict the values of the label on unlabeled data. This is achieved by classification, regression, prediction, and so on. Supervised learning is used to predict probable future events within applications having vast amount of historical data. An example is detecting likely fraud patterns in credit card transactions. Unsupervised learning. Unsupervised learning is where only an input data, P, is available with no equivalent output variables. The aim of unsupervised learning is to model the construction of the data in order to learn more about the data. Algorithms are required to discover a structure, an inference and meaning within the data in order to arrive to a conclusion. These algorithms do not have any type of historical data in order to predict the output, unlike supervised algorithms. Unsupervised learning does not have any explicit outputs and nor exists a dependency environment factor within the input variables. It brings to accept preceding predispositions as to what aspects of the structure of the input should be seized in the output. In an aspect, unsupervised learning locates patterns in the data which succors in arriving to a constructive, meaningful decision. ML has been widely adopted across various sectors within the industry to solve real-life business statements. Data is available within the whole global space, and to derive a deep understanding from it, ML is the methodology to be consumed for such derivations. We live in the golden era of innovative technologies, and ML is one of them. ML has created an ability to solve problem declarations horizontally and vertically across aviation, oil and gas, finance, sales, legal, customer service, contracts, security, and so on, due to its greatest capability of learning and improving. ML algorithms has been a great stimulus in creating applications and frameworks to analyze data, which brings in a great predictive accuracy and value to enterprises' data, leading to a sundry company-wide strategy ensuing faster and stimulating more profit. One such example is of the revenue teams across the industry. They are converting the practical aspect of ML and augmenting promotions, compensations and rebates, driving the look-for behavior across various selling streams. Figure 4 draws a mind of ML applications within some of the industries. ML applications in industries. ML has been a chosen integration within the industries for its skill to constantly learn and improve. As we have seen, ML algorithms are very iterative in nature, having the flexibility to make it learn towards a vision of achieving an optimized and a useful outcome. ML's data-driven acumen is infusing every corner of every industry, and it's starting to disrupt the way business is done worldwide. Leveraging ML has enabled processes to be recalibrated inevitably and improved for reduced cycle times, created a higher quality of delivered goods, and allowed for new products to be established and tested. The ability to influence data for more accurate decision-making in place of instinctive feel. According to a representative from Gartner, as quoted, 10 years ago, we struggled to find 10 machine learning based business applications. Now we struggle to find 10 that don't use it. ML's rise in the industry makes data a growing vital part of how a business makes decisions. Because of this, data scientists will take up a complete central focused role in organizational strategies, as data is becoming a core agent of change within a business. It is forecasted that with a wealth of data in business, given the occurrence of sensors and IoT implementation, the wide ability to influence data will be critical to building competitive advantage. ML should not be understood as a technology component, and, by the rise within the current era, it confidently is not a short-term trend. With its impact within the industries and various business sectors by bringing out toppling business models, and with its rising maturity in terms of sophisticated algorithms being advanced, it will continue to be the solitary driver in shifting the complete viewpoint in decision making and having a truly workable conclusion. Machine learning, ML, is not something new that security domain has to adapt or utilize. It has been used and is being used in various areas of cybersecurity. Different machine learning methods have been successfully deployed to address wide-ranging problems in computer security. Following sections highlight some applications of machine learning in cybersecurity, such as spam detection, network intrusion detection systems, and malware detection. Traditional approach of detecting spam is usage of rules, also known as knowledge engineering. In this method, mails are categorized as spam or genuine based set of rules that are created manually either by the user,